Given the function f of x equals the square root of x, g of x equals 3x plus 1, and h of x equals x minus 1, find part A, f plus g and the domain, part B, g times h and the domain, part C, g minus h and the domain. Solution, part A. Well, f plus g of x is defined to be equal to f of x plus g of x. So we're going to add those two functions together. The f of x function is the square root of x plus the g of x is 3x plus 1. And that's our new function, f of x, f plus g of x. The domain of the original function f would be, let's see, well, we have to have x greater than or equal to 0 because it's under an even index root. And for the domain of g, well, there's no restriction on what x can be in the g function, so it's all real numbers. We're going to take the intersection of these two, and it gives us the domain of f plus g. Line up the pertinent number, which is 0. Shade everything on the first graph that's greater than or equal to 0, the boxy bracket. Shade all real numbers in the second one, and then the intersection includes shading only in the values that are simultaneously in both sets, and that includes a 0, so there's a boxy bracket on 0, comma, infinity. That's the domain of f plus g. Part B, we're going to find g times h of x. By definition, it is the first function, g, times the second function, h. So we multiply those two together. We'll have to FOIL that. And the answer, when it's simplified, is 3x squared minus 2x minus 1. That's our new function, g times x. Now take the domain of g, not f, but the domain of g. That is, well, there's no restriction on the g function, so it's all real numbers intersected with the domain of h. There's no restriction on h. H is x minus 1, so it's all real numbers. And together, you're going to take the intersection to form the domain of g times h. Well, we have shading everywhere on both graphs, so the intersection consists of all the points that are simultaneously living in both sets, every real number. So it's everything from negative infinity to positive infinity. And finally, for part C, we're going to find the function g minus h of x, and of course the domain. So g minus h of x is the first function minus the second function. So it's the g function minus the h function. Distribute the negative sign, dropping the parenthesis, combine like terms, and we get 2x plus 2 for the new function g minus h. Now for the domain, take the domain of the first function, g, it's all real numbers, intersected with the domain of h, also all real numbers, equals the domain of our new function, g minus h. Well, again, just like part B, it's all real numbers because simultaneity for these sets that contain all real numbers together is all real numbers. That's what they have in common. It's everything from negative infinity, open bracket, to positive infinity, open bracket. Now, I'm going to leave this as an exercise for you to figure out. I want you to try a new problem. Take g over f of x. Well, when you actually calculate it, and I want you to do the work, you get 3x plus 1 over the square root of x, and the domain turns out to be 0, infinity. So you do the work to figure out why this is true.